a Miss Woody flipped production on calculating energy transfers in an ecosystem. What does the syllabus say? It says, explain how energy losses occur along food chains and discuss the efficiency of energy transfer between trophic levels. The command word explain. This means that you need to include scientific knowledge and back up your reasoning and thought processes. Because will be an important word in these sorts of answers. In an ecosystem, the energy comes from sunlight. In this simple food chain, you can see that the energy is passing from the sunlight to the grass, to the rabbit, to the fox, and is losing energy along the way. Whenever energy is transferred from one form or from one system to another, some is always lost as heat. As energy passes along the food chain, large losses from the food chain occur at each transfer, here and here, both within and between the organisms. Of the sunlight falling onto the ecosystem, only a very small percentage is converted by the green plants into chemical energy. That's here. Usually less than about 3% of the chemical energy. The reasons for this inefficiency include sunlight missing the leaves entirely, sunlight being reflected from the surface of the leaves, some sunlight passing through the leaves without being trapped by chlorophyll molecules, and only certain wavelengths of light being absorbed by the chlorophyll. And energy losses as energy absorbed by chlorophyll is transferred to carbohydrates during photosynthesis. The chemical potential energy, now in the plant tissues, is contained in various organic molecules, especially carbohydrates, lipids, and proteins. It is from these molecules that the primary consumers in the ecosystem obtain their energy supply. However, in most plants, almost half of the chemical potential energy stored by plants is used by the plants themselves. They release the energy by respiration, using it for purposes such as active transport. During these processes, much energy is lost to the environment as heat. What is left is then available for other organisms which feed on the plant. Once again, losses occur between the plants and the primary consumers. The reasons for these losses include not all of the parts of the plants being available to be eaten, such as woody tissues and some roots. Not all of the parts of the plants eaten being digestible, so that not all of the molecules can be absorbed and used by the primary consumer. Energy losses as heat within the consumer's digestive system as food is digested. As a result of the loss of energy during respiration in the plants, and the three reasons I've just given, the overall efficiency of transfer of energy from producer to primary consumer is rarely greater than 10%. Similar losses occur at each trophic level. So, as energy is passed along a food chain, less and less energy is available at each successive trophic level. Food chains rarely have more than 4 or 5 levels in them because there simply would not be sufficient energy left to support animals so far removed from the original energy input to the producers. If you can pick out a 5-organism food chain from a food web, you will probably find that the top carnivore also feeds at a lower level in a different food chain. So this diagram clearly shows the energy reducing between each trophic level, and consequently, by the time you get to the fox, there is very little energy to pass on, and the fox is our top consumer. Productivity is defined as the rate at which plants convert light energy into chemical potential energy. This definition is for primary productivity, and the units are kilojoules of energy transferred per square meter per year. Some more definitions. Gross primary productivity is the total quantity of energy converted by plants in this way. And then net primary productivity, the energy which remains as chemical energy after the plants have supplied their own needs in respiration. So what does this mean? Well, the sun here gives energy to the plant. The rate at which the plant is able to turn the sun's energy into energy that is fixed by the plant is called the primary productivity. The actual physical amount of energy that is trapped by the plant is the gross primary productivity. But as we've just heard, the plant will lose energy to respiration and other biochemical processes. So the amount of energy that remains in the plant after the energy has been lost is the net primary productivity. And this is the amount of energy that would be available to the next stage in the food chain. You sometimes get asked to do calculations on this, and the easiest way to think about it is to put it into an equation. So, gross primary productivity equals the amount of energy lost by respiration added to the net primary productivity. So, if a mature rainforest has a gross primary productivity of 150,000 and loses 60,000 to respiration, what is the net primary productivity? Well, GPP equals respiration plus NPP. So NPP is going to be GPP take away respiration, 150,000 take away 6,000, which is 90,000. And just a reminder that the net primary productivity is the energy that will be available to the primary consumers in the next trophic level. The significance of the numbers, well, an area with gross primary productivity is likely to be one that has higher temperatures, higher rainfall, and higher light intensity. Basically, one which has a higher rate of photosynthesis. They may lack seasonal variation, so they have sunlight all the time, which would allow photosynthesis to occur all year round. If you think of a deciduous forest, half the year there are no leaves on the trees, so no photosynthesis is taking place. This will obviously have a lower GPP than a forest where the leaves are on the trees all the time. You also need to think about structural adaptations of the plants, big leaves, more photosynthesis, and finally think about plant density. More plants, more photosynthesis, higher GPP. An area with net primary productivity, i.e. one that passes a lot of energy to the next trophic level, is likely to occur in organisms that are still growing. In these, the carbon is fixed into new cells rather than being lost in respiration, and that means that there is more energy to transfer to the next trophic level. A mature ecosystem will have little growth, and so that's going to fix less carbon, and so it's going to lose more energy in respiration and will have less energy to pass on to the next trophic level. What to do now? Watch the video again if you want to check the key definitions. Have a go at the SAQ questions on page 93 of your textbook, and there are answers in the back. If after that you are still unsure, then you need to come and ask for help.